Hello, so this is a revision video for AP Chemistry 5.8, Reaction Mechanisms and Rate Laws. In a multi-step reaction, not all steps occur at the same rate. The step that is the slowest is called the rate-limiting step, also called the rate-determining step. And it is this step that determines how fast the overall reaction proceeds. It doesn't matter how quickly the other steps occur, it is the rate of this slowest step that will determine the overall rate of the reaction. As a result, it is the slowest elementary step in a mechanism that determines the rate equation. A species must appear only in the rate law if it is part of or directly influences the rate-limiting step. This hopefully makes sense because the rate law shows us how the rate of a reaction is dependent upon the concentration of reactants involved. Well, if the fast steps in a reaction mechanism have no impact on the rate of reaction, then the concentrations of reactants involved in those steps don't really matter. But the concentration of reactants involved in the slow step will matter, and this is why the rate law concerns the rate-limiting step. Mechanisms can only be proposed using experimental data. Now, the rate law of an elementary step, so a single collision event between particles, can be written directly from the balanced equation for that step. This is really useful because it enables us to determine rate laws for individual steps within a reaction mechanism. For example, if a reaction A plus B plus C goes to form D plus E, has a rate law of rate equals rate constant K multiplied by concentration of A multiplied by concentration of B, this tells us the reaction must occur in two or more steps, because the concentration of C isn't included in the rate law, so therefore isn't involved in the rate-limiting step. We could propose a two-step mechanism. The first step being A plus B goes to form an intermediate, and then this intermediate reacts with C to produce our final product, D plus E. Well, the rate law for the first step here would be rate equals rate constant K multiplied by the concentration of A multiplied by the concentration of B. C isn't included because it isn't involved in this particular step. As we know, the rate law overall is rate equals rate constant K multiplied by concentration of A multiplied by concentration of B, this proposed mechanism would be consistent with the kinetic data and the balanced reaction equation. Note, however, that it is still just a prediction. We don't know for certain that this is what happens, it's just this proposed mechanism matches the data we've been provided and the balanced reaction equation.